on how it's made. Nail nippers. Jade putters. Ice cider. And water skis. Whether it's a hangnail that needs fixing or it's simply time for a trim, a nail nipper is a good thing to have at your fingertips. A nipper is a precision tool, one that offers a bit more control than lever-style clippers. The result is usually a more manicured look. Heavy-duty and made of stainless steel, the nipper nail cutter looks as if it belongs in a tool chest, and it actually works like cutter pliers. Squeezing the handles brings the curved blades at the end together for a well-rounded trim job. The handles offer a bit more maneuverability than the lever mechanism on a standard nail clipper. Production begins with these forged steel blanks. They'll make 2 pairs of nippers from each one. They load the blanks onto a carriage that transports them into a furnace. Subjected to intense heat, the steel blanks become white-hot and malleable in minutes. The foundry worker transfers a blank to a die. He moves it across the die and flips it over as a hammer slams it into the shape of 2 nail nipper shanks, each with a cutting head. It takes several strikes to create the right impression on both sides of the blank. The process transforms the narrow blank into a wider piece with 2 nail nipper formations. This is the blank before forging and now. Once the 2 shanks have been separated and trimmed, a drill cuts a hole under the blade end. This is the area where the nipper shanks are to be joined. A milling tool shaves down the area for a neat and level joint. This is the nail nipper shank before the joint work and after. They transfer the nipper shanks to a finishing machine. They bounce around in a stream of abrasive ceramic pebbles for a few hours. This rubs off the rough bits. A magnetized conveyor pulls out the steel shanks, leaving the ceramics behind, and carries the shanks forward. An employee sands the entire surface of each shank until it looks completely smooth. He brushes oil onto a shank joint to prevent rust and abrasion. It's time to rivet the 2 nail nipper shanks together. The rivets funnel into tooling above and below the nail nipper shanks. The machinery drives the rivets into the holes in the shanks. Once joined, they cannot be pulled apart without completely destroying the nail nippers. At this point, the rivets protrude slightly and could snag on clothing or other things. An employee sands each rivet until it's on the same plane as the rest of the nipper joint. The vigorous sanding makes the rivet seem to almost disappear. He polishes the inside of the nipper blades to completely smooth the surfaces. An even surface can be more thoroughly cleaned and disinfected between manicures. The blades are still blunt at this point. The next member of the team files them on an angle to give them a cutting edge. Filing too little could hamper the clearance between the blades. Filing too much would ruin the nippers entirely. He tests them on paper. If the cutting edge slips, the blades may need more work. If they slice right through, they're just right. Next, he clamps the nail nippers onto a circular bench. It revolves to meet up with a laser that etches the company logo and other information onto the shanks. After that, they drill holes and attach a spring to make the nippers easier to open and close. For the professional who'll be opening and closing these nail nippers a few hundred times a day, this is a nifty feature. They manufacture these nail nippers in batches of 300 or 400 over a period of about 2 weeks, so there should always be plenty on hand. This putter is made of jade, a precious stone traditionally used in jewelry and sculpture. Long coveted for its beauty, jade is in demand on the putting green. As tough as steel with a feel that is distinctly different, a putter made of jade is definitely up to par. The Jade putter is among a number of new clubs on the green. Along with crystal quartz and fossilized vegetation known as petrified wood. To make a jade putter, they head for the hills, specifically a nephrite jade outcrop in Wyoming. Here, the putter maker finds a 6-meter wide vein of nephrite. This stone has taken 2.5 billion years to form and develop a very hard and fibrous crystalline structure. The carver selects slabs that are thick enough to shape into 4 or 5 putter heads. This one has weathered to a rusty color, but it should clean up nicely. The color of Wyoming jade ranges from white to green to black. He strikes the slab with a sledgehammer a few times to break it down to a more manageable size. He slices through one of the cut pieces with a rock saw, while flushing it with coolant to save the diamond blade. He makes 9 or 10 cuts to rough out the triangular mallet shape of the putter head. He slices off the ends to complete the basic shape. Next, he anchors the jade in a wooden jig and cuts on an angle to profile the sides of the putter head. He slices off a back section to give the putter clearance from the ground when swung. This putter has really taken shape. He removes material from the corners to center the mass behind the golf ball for more striking energy. He sands the edges to round and soften them. He's careful not to remove too much in one place because that would affect the symmetry. He then polishes the entire piece of jade against diamond abrasive belts. It's an intensive process that takes about 2 hours. He aims a drill and cores into the putter head on a 20-degree angle to make a hole for inserting the putter shaft. A perpetual flow of water keeps the diamond core bit cool and also flushes out the little bits of filings. He gently taps the drilled core to jar it so it falls out of the putter head. A laser emblazons the product name onto the jade, swiftly etching it into the surface. The putters can be customized with the customer's name and logo. He swabs gold-colored paint into the laser etching to make the letters really stand out. The swabbing leaves a lot of residual paint around the letters, so he rubs it off. He sprays the putter with a wax-based gloss to seal the stone. He then buffs it against a felt belt to give the jade a satiny sheen. He mixes epoxy ingredients to attach the shaft to the jade putter head. He deposits epoxy in the hole in the shaft. He inserts the steel shaft into the 20-degree angle hole. The angle of the hole positions the putter shaft to match the golfer's upright stance. Once the pistol-style grip has been slipped on, he applies a metallic look decal just below it. The decal displays company contact information in the event of a problem that doesn't have to do with the golfer's technique. After cleaning and inspection, this jade putter is ready for action. Putters carved from jade and other materials are crafty additions to the golf club arsenal and could lead to some artful moves on the green. Ice cider is an alcoholic drink made from fermented frozen apples or apple juice. It's also known as apple ice wine, as it's produced the same way as ice wine but with apples instead of grapes. It's typically served with foods such as foie gras, cheese, fruit, and dark chocolate. There's a world of difference between ice cider and regular cider. Regular cider is made from fresh apples, whereas ice cider is made from frozen apples or frozen apple juice. And while cider can be a non-alcoholic beverage, ice cider is always alcoholic. There are 2 methods for making ice cider. One is to leave the apples on the tree to freeze over the winter, then pick them and press them. The other method, which we're about to see, is to harvest the apples in the fall when they're ripe, press them, then freeze the juice. The apples are always hand-picked at perfect maturity, and always right off the tree. An ice cider producer never uses fallen apples because they often get damaged when they hit the ground and then pick up bacteria from lying there. This producer uses different varieties of apples to make several types of ice cider. The one we're about to see is made from Empire, Spartan, Cortland, Macintosh, and Golden Russet. Straight from the orchard, the apples go onto a conveyor belt, which feeds them into a multi-stage press. The first part of the press crushes the apples into what's known as pomace. A screw conveyor moves the pomace onto a mesh conveyor belt, which transports it through 5 stainless steel rollers. Each roller applies 125 kilograms of pressure, progressively extracting the apple juice. The juice drains down through the mesh conveyor belt to a vat below. From the vat, the juice is pumped into a large container made of food-safe plastic. The container holds 1,000 liters. However, they leave 50 to 100 liters of airspace to leave room for expansion when the juice freezes. At the end of December, they haul the containers outdoors. The juice stays outside from 40 to 50 days, during which time the water in it freezes, leaving unfrozen concentrated juice at the bottom of the container. Workers measure the sugar content daily, and once it reaches a certain level, they pump the juice indoors into temperature-controlled stainless steel tanks. Then they add yeast to kickstart fermentation, the conversion of those natural sugars to alcohol. Every day, they measure the sugar level to monitor the fermentation process. When they hit their target, which typically takes between 40 and 50 days, the juice has transformed into ice cider, with an alcohol content of 10.5 to 11%. Ice cider is bottled just like wine. The corking machine automatically pops in a cork as soon as its sensor detects the presence of a bottle. The next machine slips a plastic seal over the mouth of the bottle, then heats the plastic to shrink the seal tightly around the cork. Finally, an automated labeling machine simultaneously applies self-sticking labels to the front and back. It isn't only the apple variety which determines the flavor, it's also the production method. The process we've just seen, called cryoconcentration, produces ice cider with a strong, fruity flavor. The other method, called cryoextraction, letting apples freeze on the tree, then pressing them, produces ice cider which tastes like baked apples. Water skiing was invented in 1922 by an American teenager named Ralph Samuelson. With his brother pulling him by motorboat, he tried first with skis made of barrel staves, then with snow skis, then with skis he made out of pine boards 2.4 meters long. This type of water skiing is known as slalom, winding through a course on a single water ski, 1 foot behind the other, in boots mounted to the ski. The core of these top-of-the-line competition slalom skis is high-density PVC foam, exceptionally strong yet lightweight. A computer-guided machine cuts the ski shape, then pockets to receive various components. Workers flip the core upside down, and the machine shapes the bottom. Workers then turn the core right side up again and fill the pockets with glue. They insert an alignment tab in the tail pocket to help correctly position the core in the mold. They install fiberglass reinforced nylon blocks in the others. These will anchor threaded inserts for mounting the boots and the ski's fin. Now they begin building up the water ski with multiple layers of carbon fiber, an ultra-strong fabric. They apply the first layer to the bottom, wrapping it around to the top. This will prevent the ski from twisting. After stapling down the carbon fiber and trimming off the excess, they saturate it with resin and apply carbon fiber to the top of the ski. Depending on the model and its performance specifications, they wrap the core in up to 7 layers of resin-saturated carbon fiber, controlling the flex in select areas along the way with additional patches. Then they top the ski with a layer of woven synthetic fabric to prime the surface for the decorative graphics. On the bottom of the ski, they apply a sheet of super lightweight polymer. It creates a white background to highlight the printed polyester sheet of decorative graphics. They coat it with a special resin, which cures into a hard, hydrodynamic surface that increases the ski's speed. The graphic design that decorates the top of the ski is printed on nylon. They mount it to the top part of the ski-shaped mold, then lay the wrapped core into the bottom part. A heated press closes the mold, compressing the contents under high pressure for 9 minutes. This bonds the layers, forms contours in the ski, and adheres the graphics. The pressure squeezes out excess resin along the perimeter, so once they remove the ski from the mold, they cut off the excess with a bandsaw. Then, with a custom-made router bit, they precision trim to exact specifications. Next, a 3-phase filing of the ski's edge. First with a large file, then a small file, then with either a razor blade or medium grit sandpaper. Then, with the help of a template, they drill 18 holes into those fiberglass reinforced nylon blocks in the core. They screw a threaded insert into each hole and it locks into the block. There are more inserts than are actually required for mounting the fin and attaching the ski boots. This gives the skier different positioning options. Now the last edge sanding with fine grit paper. After wiping down the entire ski with an alcohol-based cleaner, they install the final and most important component, the fin. It's made of aluminum that's chemically treated to be corrosion-resistant and ultra-durable. The fin's position critically affects the ski's traction and stability, so they use a micrometer to measure to the millimeter, securing the fin precisely where the design engineers specified in the performance maximization sweet spot. Nonetheless, competitive water skiers typically readjust the fin to their own preferences, in hopes of leaving competitors in their wake.